This is part 2 of section 8.2. We are talking about arithmetic sequences, and arithmetic sequences are the kind where you're either adding or subtracting the same number every time. In 8.1, we also talked about finding the sums of sequences, and we used summation notation, which looked like this. And we were we knew we had to, find each number in the sequence and then add them up. Now, the thing is, if you know that you have an arithmetic sequence, there's a shortcut, and you can use this formula. The sum, which we call S sub n, of the first n terms, so if I ask you for S sub 20, that means you're adding the first 20 terms, of an arithmetic sequence is given by this. The sum is equal to n divided by 2 times your first term times your nth term. So if I'm looking for the sum of the first 20 terms, I would do 20 divided by 2 times the first term times the 20th term. Okay? Now, it seems a little bit weird that we don't have to worry about what our difference is every time. But it just works out that way. So let's say, just to kind of show you what's happening here, if I'm going to add the numbers 1, 2, 3, 4, ... plus 98, plus 99, plus 100. I'm going to add the first 100 terms. Now look what happens here. I could sit and I could add them all up, or I could be strategic about how I pair things. If I add these two together, I get 101. If I add these two together, I get 101. If I add these two together, I get 101. Okay, notice I'm getting the same value every time. Now, how many pairs am I going to have if I pair things up like this? I'm going to have 50 pairs. I would have 50 pairs and of 101s, so I could simply do that multiplication and have the entire thing added up. That's what's happening here. This finds how many pairs you have, and then here you're adding up these two. So I'm adding 1 plus 100, which gives me the thing I'm at. Every pair adds up to. Okay, so that's where this thing is coming from. All right. So the first thing we need to do here is we're supposed to find the sum of the first 25 terms of this sequence. Okay. Now to use this formula, I need n, I need a1, and I need a sub n. Okay. Now n, we're supposed to add the first 25 terms, so our n value is 25. My a1 is the first term, which is 7. Now I need a sub n, which is a sub 25. Now I don't have this. Okay. This means I need to find the 25th term of this sequence. Now how do I find the 25th term? That sends me to this formula right here. Okay. So a sub 25 is going to equal a1, which is 7, plus 25 minus 1 times d. Well, I don't have d yet, do I? So what is our d value? What am I adding or subtracting every time here? Well, my numbers keep getting bigger, so that tells me my d value should be positive. So what did I add to 7 to get to 19? That looks like a 12 to me. So let's double check that. If I start off with 7 and I add 12, I get 19, and then if I add 12 again, I get 31 and then 43. So that looks correct. So that tells me that this is 7 plus 24 times 12, which is 7 plus 288, which is, so add 7 to that, and you get 295. Okay, so now let's come back up to here. The sum of the first 25 terms is 25 over 2 times A1, A1 is 7, plus A sub 25, which is 295. Okay. This is, now first of all, if this ends up being a division that doesn't work out, where you're asked for an odd right here, these two are going to add up to an even number. This fraction always goes away. Okay? So I'm going to add 7 plus 295, except I should add that to get correctly. 295, I get 302. Okay, if you think of 302 over 1, like I said, this should always cancel out. Either this divides out evenly, or you're going to be able to cancel right here. I can divide both by 2, divide that by 2, and I get 151. So I end up with 25 times 151, and the sum should be 3,775. Now, if you wanted to, you could list all 25 terms and then add them all up, and you should get this. It should work. I'm not saying you really want to do that, but it should work. Okay? So let's try this one. That's a 40 right there. I want to calculate the sum from I equal 1 to 40 of negative 2i plus 6. Now, at this point, we do not know for sure that we have an arithmetic sequence. So what I'm going to do is I'm going to start plugging in these values and look at the sequence. Okay? If I plug in 1, when I equals 1, what do I get? I have negative 2 times 1 plus 6, which is negative 2 plus 6, which is 4. So this is 4 plus, if I do I equal to 2, I have negative 2 times 2 plus 6. So that would be negative 4 plus 6, which is 2. So plus 2. Plus, when I equals 3, I have negative 2 times 3. You always want to go out several, because right here I could be subtracting 2 every time. Maybe I'm actually dividing this by 2 every time. You need several terms before you can establish the pattern for sure. So this would be negative 2 times 3 plus 6. Negative 6 plus 6 is 0. Okay, let's do one more to be sure we have a pattern. This would be negative 2 times 4 plus 6. Negative 8 plus 6 would be negative 2. So plus negative 2, and then I would continue. It looks like I've got enough of these to say that my D is negative 2. I am subtracting 2 every single time. Okay? So if I look at this and I want to find the sum of the first 40 terms, I'm looking for S sub 40. That means our N value is 40. Our D value is negative 2, so we verified that it is arithmetic. Our A1 is 4. Okay. Now to find S sub 40, I need N, which I have. I need A1, which I have, but I don't have A sub N first yet. So I need to find A sub 40. And that means using this formula. This is equal to A1, which is 4, plus N minus 1, so 40 minus 1, times D, and our D value is negative 2. So I have 4 plus 39 times negative 2. Okay, 39 times negative 2 is negative 78. So this is 4 minus 78, which would be negative 74. So the sum of the first 40 terms is N divided by 2, 40 divided by 2 times your first term plus your 40th term. Okay, so have this one divides out evenly. So I have 20 times, this is going to be negative 70. 20 times negative 70 is negative 1400. And that will be your final answer.